Okay, so the book writes it in what's called a book method, which is to use this notation. They're still using the x to mean multiply because they feel that most people are familiar with it. Slowly that'll sort of be taken out of the books, and x is used as an unknown quantity in algebra, so we use it for a different reason. All right, but the point is we want to multiply these two things. Now, with multiplication, the order does not matter. It's like addition, because really multiplication is repeated addition, so it has the same properties as addition. So you could have this first and this second, or vice versa. You can mute them, it doesn't make any difference. So you set it up however you'd like to. Let's say 3.6 on the top, and the 0.0004 on the bottom. There's the x to indicate multiplication. Our first job is to get the decimal points. We're not going to do that. We're just going to multiply the whole numbers. So 4 times 6 is 24, 4 times 3 is 12, and 2 is 14. That gives us 144. I put the decimal point there because now we're going to manipulate that decimal point to fit our situation. And our situation says we have 1, 2, 3, 4, 5 numbers to the right of the decimal point. If you combine the top and bottom factors, you have 5 numbers. So you force this to have 5 numbers to the right of the decimal point, meaning you move this one to the left, 1, 2, 3, 4, 5. And fill in with the zeros. You can even put a leading 0 in there. So that will be the result. So the number of times you move to the left is the same as the sum of the place values to the right of the decimal point in the two numbers you're multiplying. Okay? Anything else in 4.3? And labs here. Labs are good ways to review for a test. Savannah?
Is there a time when you only count the zeros? When you only count the zeros that are before the decimal? And then you
No, not when you're multiplying, no.
But when you're adding and subtracting?
When
you're adding and subtracting decimals, you only count the zeros, or do you count all the numbers? Like how there's a 4 before, if you were adding, would you go over 5 times also?
I think what you're thinking about is the multiplication by 10.
Oh, yeah.
Yeah. Multiplication by 10 or powers of 10, then you do count the zeros and you shift the decimal point by that.
So you don't count the other numbers?
Yeah, it's just the zeros.
Just the zeros? Okay.
Yeah.
That's what I was thinking.
Okay, any others in 4.3? Yes, just
61?
61? 61 or 51? $61?
Yeah.
Okay. Okay, it says the most stolen make of car worldwide is Toyota. For recent year, there were 400,000 Toyotas stolen. They want you to write the decimal number representing each word name. So they want you to write the decimal for 400,000. Now, 400,000 is what's called a whole number. In other words, it does not represent any fractions. You can't steal a fraction of a car, right? Okay, so this is a whole number. And it's the standard way of writing whole numbers. You simply write it as 400 in the thousands period, and then nothing over here in the ones period, and you put your period marker in there, a comma. That's it. Now, if you wanted to write, you want to emphasize the idea of a decimal, you could put the decimal point there. I mean, the only place that would be recognized is in this class. You go outside of this class and people are saying, what's wrong? Is there a spot here on the... Yeah. But, you know, what does the book want? They don't care. 400,000 without a decimal point is fine. It's a whole number. Okay, any others?
Would there ever, you see how there's in the front, there's 1 0, would there ever be like 2 zeros?
No, I've never seen that. what you're doing, when you put that in the front like this, what you're doing is being kind to the reader. You're saying, I'm not making a mistake, there really is nothing there. Okay? See, there's no difference between this number and that number. They're exactly the same number. So this is for, you know, being considerate for a reader. That's what it's for. Okay, anything else? Or let's go on then. Next topic is dividing decimals. As soon as the pencil sharpeners you can't do this with pencil sharpeners.
What, sorry?
It's okay. All right. Now, remember the problem with multiplying decimals was a problem basically about what to do with the decimal points. I mean, multiplying decimals is multiplying whole numbers except for what you do with the decimal point. And the same thing is true with dividing decimals. Dividing decimals is almost identical to dividing whole numbers. Not quite, but it's very close. Except what do you do with the decimal point? And so once again, what we're going to do is figure out how to do a decimal division by an example that we can do through fractions, and then figure out, well, what does that mean about the long division process? It's going to give us some hint as to what to do with the decimal point. So your book starts out with this particular problem. They start out with 3.5, or 3.5 if you wanted to say it without decimals, divided by 7. Okay, now again, we're switching over to fractions, not because this is the way you do it, but because it will tell us what to do with the decimal point. Okay, we could do something like this. This would be the same thing as 35 over 10, huh? This is, if you want to, you can think of it as, put this over 1, multiply the top by 10, and multiply the bottom by 10. That gets rid of the decimal up there, right? So there's a whole number, 35. 10 times 3.5, 35, 10 times 1, 10. All right, now we want to divide by this. Okay. Dividing by 7 is the same thing as dividing by 7 over 1, because 7 is 7 over 1. We're trying to switch it over to a fraction problem. So now we say, well, sorry, I don't divide fractions. I'm in this class, and we are told not to do that. We multiply by the reciprocal. So we get the reciprocal of that. Flip it over. 1 over 7. Okay. So now what we have is the ability to cancel. 7 goes into that once, it goes into that 5 times. Multiply tops, multiply bottoms, 5 over 10. Now that happens to be a decimal fraction.
Well, if the 7's on the bottom, why wouldn't it be 35 over 7?
The 7's not on the bottom anymore because we canceled. We divided this by 7, and we divided that by 7. In other words, we're cross-canceled. Yeah. Okay, but this, in terms of a decimal, would be 5 in the 10th position, which puts it right there. And you can write it with a leading 0, 0.5. Okay, so we know that this is the right answer because we've done it through a process that we trust, which is the multiplication of fractions. Okay, so now when the time comes to switch over to a decimal division process, then the 3.5 will be the dividend, and the 7 will be the divisor. We're using the same words, the same sign, the same process as we did for whole numbers. It's just that now we've got a decimal and the dividend in there. Okay. All right. Well, 7 into 35 is easy to do. Obviously, it's 5. But we can't end up with 5. We've got to end up with 0.5. So if we put a 5 up here, which is what we would do if we didn't have a decimal point there, we've got to realize, but we do have a decimal point in here, which makes the process be simply bring that decimal point up into the quotient. Exactly where it is, take it straight up, like that. And then you get the right answer, you get 0.5. So that helps in terms of doing a long division problem. So let's do some more just to get the practice of it. We've got, your book writes it this way, 30.55 divided by 13. Okay, that's fine for a book, it's fine for calculator entry and stuff like that, but it's not long division. That part must be the divisor, and the rest of it is the dividend. Okay, so we want to do this process. Well, 13 does go into 30, we can actually do that. But remember, bring that up right there before you start, so you'll know where the correct decimal point is, then go ahead and divide. 13 into 30, 2 times, 26, subtract, remainder 4. Now with decimal division, we do not use remainders. What we do is keep on dividing.
Excuse me, I just wanted to let you know you have some.
Did you see?
He wanted to let you know you have some blood on your face.
Yes, I know.
Yeah.
I'll survive. It's just razors, that's all. All right.
Just wanted to let you know, that's all.
So we have a remainder of 4, and we do what's called bring down, huh? So we put a 5 there. So now we divide. 13 into 45. How many times would that go? 3? Let's try 3. 3 times 13 is 39. That leaves your remainder of 6. Again, bring down. And 13 into 65 is 5. And that hits it on the button. Okay, 0 remainder. We're done.
So what happens if we do have a remainder?
If we do have a,
Remainder.
well, we keep going.
It just keeps going?
We just keep going.
Okay.
If you run out of these kinds of numbers, you put zeros.
It just keeps putting zeros?
Yeah.
Okay.
So we'll do something like that. Okay, so the answer to this, with the correct decimal point, is 2.35. Because we brought the decimal point up first before we started doing the dividing. Okay, let's do some more. So let's take 3.5 and this time divide it by 4. Again, this is the dividend. The first number is the dividend. It goes underneath the division sign, and this is the divisor. It goes outside the division sign. So it looks like that. We've learned we bring it straight up. There it goes, right up there. Okay, 4 into 35 would go 8 times, huh? 8 times 4 is 32. Subtract. There's a remainder of 3. And this brings up Lawrence's question. What do you do now? What you do is you put more zeros on the dividend. So it looks like this. And you go as far as you need to go. Just put a bunch of zeros out there. And keep doing bring downs. So bring down that 0. 4 into 30. 7, huh? 28. Subtract, remainder of 2. Bring down another 0. 4 into 20. 5. So there it is, 20. Subtract 0. And now it wouldn't make any sense to go any further. You get nothing but 0. Because that's all that's left. So that's the answer. This is, right with the leading 0, 0.875. Or if you wish, 875 thousandths. All right, let's do a few more of these because things change here and there. I've already talked about the fact that the decimal system is very good for calculation, and the world runs on it. But it has problems with fractions. And actually, when we're doing division of decimals, we're actually doing fractions, because every fraction is a division problem. Now we have to stop leading you around the potholes and jump right into a pothole, okay? So you'll see what the problem is with the decimal system now. It doesn't look like there'd be any problem. It looks like a perfectly natural division problem. And you say, well, what's wrong with this one? Well, we'll see. 1.7 divided by 30. I mean, that doesn't look very different from what we just did. But try it and see what happens. All right, 30 is a divisor, 1.7 is the dividend. There's the decimal point up there. We're ready to go. Well, we can't divide 30 into 17, so we put a 0 on there. And we get, how many times is 30 going to 170? Well, 5 30s would be how much? 150, yeah? Yeah, we should try 5. Okay. Now notice, there's a 0 that goes there because we couldn't divide it into 17, so the 0 goes there. But this is a 5. And 5 times that is 150. Okay, there's a remainder. 0, bring down. As long as you got remainders, keep bringing down zeros. Okay? 30 into 20
Can do.
No.
doesn't go in, does it? Okay? 30 into 200.
6?
6 times. Okay? 6 times 30 is 180. And what do we get here? 20
Same thing
remainder
over
again.
and
20 again.
Yeah,
Okay.
again and again and again.
200. 6. 180. This is
Then
getting
you put,
boring.
you do the 6s with a line on top?
Yeah. All right. What we're getting is a repeated decimal. It keeps on going, and it keeps on going forever. It doesn't stop. It's an infinite repeater. So this little fraction up here is not a nice one to work with. The way we write this, by the way, is 0.0506 bar. And that bar is, again, only known in this room. If you go outside to the real world and you write a bar over a number, they'll say, what are you, nuts? You know? It means that's what repeats. It's only that number that repeats. Let's do another one. Sometimes more than one number repeats. Divide 11 into 68. Looks like a perfectly natural thing to do. The decimal point for the 68 is there, so bring it right on up. And let's start. 11 into 68 would go, well, 6 times. Huh? Yeah. 66. Leaves you with a 2. All right, let's start the bring down process. 11 into 20. That's 1, huh? That gives you a 9. 11 into 90. That would be 8. The 11s are so easy to work with, aren't they?
Yeah.
Yeah. 88. And that gives you a 2. Whoops, here we go. Notice what happens.
Yeah.
The moment you get a repeated remainder, okay, 20 there, 20 there, okay, the moment that happens, or 2 here and 2 here, that's it. This is a repeater, okay? So that means we're going to have to do a 1 again, and guess what will happen after that? An 8, an 8 again, and then a 1 again, and an 8 again, you know. So we write this as 6.18, but you'll only put the bar over the part that repeats, okay? You don't put the bar over the same. This is part of 1H.
Is it just the part that repeats?
Just the part that repeats. Okay. So what do we do if not only the dividend is a decimal, but the divisor is a decimal? Actually, that's fairly easy to handle. Here's an example of it. Suppose we had 0.56 divided by 0.7. Okay, so that divisor now is going to be a decimal. Well, you could write this, if you wanted to, as 0.56 over 0.7, like that. We know how to do this if that denominator or divisor is a whole number. So we could convert that thing to a whole number simply by multiplying by 10. So if you multiply this by 10 here, of course you have to multiply this by 10, you're going to change the value of the fraction. So this is going to be 10 simply moves it 1 to the right, so this will look like 5.6 divided by 7. Okay, that we can do. As long as you got a whole number divisor, you just divide normally. So here we go, 7 into 5.6. And now take that new decimal point and put it right up there where it's supposed to be. Now the procedure is exactly the same. Well, we go more than 7, we go 8 times, huh? That's exactly 56. Okay, subtracting, get 0, and that's it, you're done. That's 8 If you want to, you can write it as 0.8. And that is the correct place for the decimal point for the division of these two. All right. Oh, let's try this. We have 0.005 divided into 3.1. Okay, now resist the temptation to bring that decimal point up now, because we don't have a whole number divisor yet. We've got to get that whole number divisor before we bring the decimal point up. So we're multiplying this by 1,000, so it'll go 1, 2, 3. We'll go over there, make it a whole number. We have to do the same thing here. 1, 2, 3, and fill in with the zeros. So the decimal point is now shifted, and it goes up there. Now all of that gets rather complicated, so I suggest writing it like this: 5 into 3,100, and there's the decimal point like that. Okay, so shift your decimal points to accommodate that whole number divisor, then bring it up into the quotient area. All right, 5 into 31, there's a 6 there, and so forth. And a 2, and a 0, and that's it. So this number is 620. Now that's sort of surprising, I think, because you started out with 3.1. This is 3.1 divided by 0.005. And that's a rather small number, but this is an extremely small number. Okay, this is 5 thousandths. There's going to be a lot of 5 thousandths inside 3.1. Turns out it's 620. This is a classic one that everyone has in their textbook. Might as well look at it. 50 divided by 1.1. Okay, so the 1.1 is there, the 50 is here, and we start going. But we don't have a whole number, the divisor, so we shift. Shift goes over like this, so we take this over 1, put a 0 there, and a 0 straight up above that. So it's 11 into 50, which is, of course, 4. That leaves it with a 6. Bring down 11 into 60, 5, 55, subtracting 5. Then start bringing the zeros in. 11 into 50, that's just what we did up here. 4, 6, bring down. So you get the hint now, right?
Yeah.
Yeah.
You gotta put the bar.
So, how would we write this? Now, this is the one that's tempting to make a mistake on. Okay, the way you'd write it is 45.45 with the bar only on the second 45. You'd never put the bar on the whole number part, only on the repeating part of the fraction. This is the fractional part of a decimal. That's what repeats before 5. Now, when your divisor is 10 or a power of 10, things get very simple. So let's take a look at that. They start out by doing 10 into 3.6. All right, that's whole numbers, so we don't need to do anything about shifting decimal points. And that goes in there 3 times, and so forth. So it becomes 0.36. That does the entire thing, 0 remainder, we're done. So what was accomplished by multiplication by 10? Simply moving the decimal point 1 to the right. That's all. Same thing would work if you were dividing by 100 into 3.6. Again, bring it up. Doesn't go in there, so it's going to be we'll have to add some zeros in order to get this to work. So that's a 0. 100 into 360, of course, is 3. 6. So what happened? Well, basically, we shifted it 2 to the left. Here it got shifted 1 to the left, like that. Here it got shifted 2 to the left. And this, I think, is what Savannah was talking about, and that is, you just count the number of zeros in your power of 10, and then shift the dividend that many spaces to the left. Now, of course, when you're dividing by power of 10, or 100, or 1,000, you get smaller and smaller numbers. Therefore, you have to shift to the left, not to the right. Well, we saw that when we were talking about powers of 10 and powers of 1/10 in the last section. So what it amounts to, they have an example here, 214.3, and you want to divide that by 10,000. Here's your dividend, here's your divisor. No need to set it up as long division. It's very easy. Just count the zeros. 1, 2, 3, 4. All right, take that decimal point from where it is. 1, 2, 3, 4. So there it is. It's going to be 0.02143. As long as you've got powers of 10, it's really easy. Now, got your book, page 251, up at the top there. Here's example 9, rounding a repeating decimal. They said when we did this problem, we found out that the 4, 5 repeats. And if we wanted to check decimal division, you always check division by doing a multiplication. And so what you would do is you would take that 4.45 that keeps on going forever, and so forth, and multiply by 1.1, and you better get 500. Or, I'm sorry, you better get, if you multiply by 1.1, you better get 50. Well, the problem is, how do you multiply an infinite repeater by another number? We don't have the ability to do that. It's not within the scope of our course, that's for sure. So what they say is, all right, just make an approximation. Round this to the 100th position. Now, if we rounded this to the 100th position, really what this looks like is the following. All right, there's the 100th position. Go next door, 5 or greater, no. So rounded to the nearest 100th, this is 45.45. Okay, if we multiply that by 1.1, that would be a check to see how close we're coming to the actual dividend. All right, 1.1, multiply. Quotient times divisor equals dividend. This gives you 5, 4, 5, 4. This gives you exactly the same thing, but over 1. Now you add them up. And 1, 2, 3, 1, 2, 3. So what you get is 49.995. That's pretty close to 50. And that's what you started with. This was 50 divided by 1.1. That's not far from 50. So you can actually check these repeaters simply by multiplying. Test this tomorrow.
Is this going to be on the test?
I'm sorry?
Is this going to be on the test? For this section?
Certainly. Yes. This is a similar problem. They say 47.3 divided by 5.4. And what they're saying here, the request that the book has is round the quotient to the 10th place. Okay, now let's see what that means. First of all, let's set up the division problem. 5.4 into 47.3. Shift it over 1, shift it over 1, bring it up into the top. Okay. Now, they're saying they want this to the 10th place. Yeah. All right. Now, here's your quotient area. And when they're talking about they want it rounded to the 10th place, they're talking about the quotient wants to be rounded to the 10th place, okay? Obviously, this was to the 10th, but we shifted it out because we need a whole number here. All right, so what do? Well, we're going to have to do enough dividing so that we can go around to the 10th place. In other words, we have to get this number to the hundredths place. That's the only way we can round to the tenths, because we have to go to the one next door and see if it's 5 or greater. So let's try it. All right, 54 into 473 would be, well, probably 8 or something like that, huh? Shall we try it and see what happens? Well, it's going to be close.
Yeah.
Huh? That's it, okay. Bring it down. Okay, 54 into 410.
7.
Yep. 7. $32. 54 into 320. 6, huh? I think 6. Let's see. Let's see what happens.
The book says 5.
Oh, well, you're right. Well, we just missed it. Okay, 5. Okay, now, the point is, they told us to stop at the 10th place here in the quotient, huh? Okay, is that 5 or greater, the next one? Yep, it is. So this becomes, as a rounded quotient, it becomes 8.8. 8.8, huh? The point is that when you're rounding to a certain position in the quotient, you have to go one more position to figure out how to do the rounding. So you have to go to the 100. Believe it or not, this stuff is useful. And I know you all have your calculators with you and your cell phones when you go out to eat with a bunch of friends, right?
Yeah.
So it's real easy to get these division problems done. But just think how impressive it would be if you started writing on the tablecloth and did a long division right there, huh? And then the restaurant. A dinner costs $45.80 and the bill is to be split equally among 5 people. It's Taco Bell. How much must each person pay? Okay, $45.80 divided by 5. That's basically what's happening. Our money system is a decimal system. Okay, 5 into 45.80. All right, that's a whole number. Just bring the decimal point straight up. We're ready to go.
9.
5 into 45, 9. That hits it on the button. So we bring down the 8.
7.
No, that goes in there once. That's going to be 5. Subtract 3, bring down to 0. 6, yeah.
Yep.
And finally we're there. So in other words, each person owes $9.16 plus tax and tip, and you know what. And then you have the indigestion afterward.
Yeah.
Okay. In a recent year, the world record time in the men's 400-meter run was 43.2 seconds. Amazing. What is the speed in meters per second? Okay. So we know 400 meters in 43.2 seconds. And that's exactly what we're looking for, meters per second. So we want a division problem like that. So it's going to be this, 43.2 into 400. Now, we don't want to put the decimal point up in the quotient yet because we have to go over one. It's going to be 4,000. Okay. So 432 into 400 doesn't go into 4,000. What? So it's 9 times. Okay, 9. This is one where you got to borrow an awful lot. Okay. 432 to 1,120, 2 times, no? Well, maybe more. No, I don't think so.
You know,
Okay. 432 into 2,560. 6 times? Probably like 5, no, I think 5. Close though. No, that makes it. Okay, so about 9.25 liters per second. A meter is more than a yard. Okay, this is a meter stick actually. This is longer than a yard. Imagine 9 1/4 of these lined up across the room. This person covers that in a second. That's fast, you know? Almost 10 of these in a second. Amazing. It's all these high protein diets and stuff like that. All right, this is 4.4. I'm also going to write down the sections for the test tomorrow. Please have your homework ready and stapled and frizzy edges off before getting here. This will be homework for Monday, not for the test.
Okay, so we don't have to turn this in tomorrow?
No,
Can't we?
you can if you want to. Okay. Section.
Is that 4.4 to 4.4?
4.1. Sorry. 4.1 to 4.1. If anyone didn't get their lab, it's up here, or if anyone did not take the lab on Monday and wants to copy of
The Judith Parker.
I did have a lab.
did.